Alright guys, as promised, this video is going to introduce friction into our Newton's second law problem. So I'm going to start with my favorite, our lovely box here. And this time I'm going to add friction. So we have our applied force. For now, we're not going to put it at an angle. We have friction. We have gravity, which is equal to mg. And we have the normal force. Just like before, we are going to establish positive direction and establish a coordinate system. Here's x, here's y, this is plus, this is minus. Now, with this particular example, none of our forces are at angles, so I can simply apply signs based on my coordinate system. And this should be positive rather than negative. So let's do that. Applied points to the right, so it is positive in the x direction. Friction points to the left, it is negative in the x direction. Normal points up, positive. Gravity points down, negative. Once direction of motion, coordinate system, and signs have been applied, I can start writing out Newton's second law. Now, my goal is to get acceleration of this object as specific as I can, which means I need to take friction into account. In order to do that, I'm going to begin just like I always have with writing out F net x equals max. Again, we are being specific as to what direction we are looking for as far as forces are concerned, and as a result, we will get an answer that is specific to that direction. So, the forces in the x direction are applied and friction. So I have FAP minus friction equals MAX. However, I could stop there, but I said we want this as specific as possible. What does that mean? Now, something that I forgot to write is that this surface has a frictional coefficient mu that is specific to this mass and this surface. I want to take that into account. The way that I do that is I need to recall that friction has a relationship between the normal force. So friction is equal to the frictional coefficient times the normal force. Now, a note on frictional coefficient. Two things. One, it is material specific, meaning that if I have, for example, a block made of wood and a surface made of asphalt, there will be a mu specific to those two materials. If I have a block of wood and a surface of ice, there will be a mu specific to those two materials. Second thing, it is a number without units, and it is between 0 and 1. So between 0 and 1. Okay? We can go into further detail, but for now, we're not going to. Now, based on that information and based on the relationship that I have for friction, the thing that I do not know to complete this is normal force. And that is where, with the previous two examples, us getting into the habit of writing out F net equals ma, Newton's second law, in the y direction is so important. I can't get normal force without it. Do it every time. Make life simpler for yourself. So we have F net y equals m ay. V y is 0. This object is moving horizontally. There is no velocity vertically, therefore Vy is 0. As a result, AY is 0. Therefore, this term drops out. Now, going back to my picture, the only forces acting in the y direction are normal, which is positive, and mg, which is negative. Write those in. We have normal minus mg equals 0. Normal is equal to mg. From there, I will apply the relationship for friction that I have, which says friction is equal to mu times the normal force, which I know is equal to mg. Almost done. From there, I'm going to take this value and I'm going to put it in to my F net equals ma equation in the horizontal direction to obtain my final expression. So we have FAP minus mu mg equals max. AX will then be FAP minus mu mg divided by mass. I hope this is helpful, guys. Keep practicing. Thanks. Have a wonderful day.